There will be no interruptions today. This is far too important.
Hello and welcome to Chapter 5, Section 4, Sum and Difference Formulas. Now, today's lesson will be based around these 4 to 6 different types of equations which help us to redefine some of the different angles and whatnot. So basically what we're hoping to achieve today is how to effectively use these formulas which have been given to us in these handy-dandy boxes inside of your book. Essentially what all of these are is, if you don't know the sign of, let's just say the sign of W. Well, what if I can break W up into 2 numbers that I do know the sine and cosine of quite simply? For example, all those numbers that are on your unit circle that are, probably ingrained into your mind already, you may not, know the sine of, I don't know, let's say 75 degrees. However, you do know sine of 30 as well as the sine of 45. So by splitting sine 75 into sine 30 plus 45, you could use a sum formula in order to solve it. Or, in other examples you might use a difference formula. But that's basically what we're looking at. For when you don't know the actual sine value of a specific degree or radian.
Check out this clicky
value. And you want the exact value. You don't want to go to the calculator and get some decimal approximation. So you're going to use sum and difference formulas. So let's take a look at how they work. Our first example is cosine 75. And it's actually the number that I just chose. So kind of gave it away a little bit. This is going to be the same thing as cosine 30 plus 45, right? I can split it into 30 and 45, 2 numbers that I do know the cosine and sine values of quite easily. Now, if I go back, I'm doing the sum formula using cosine. So that means I'm going to look at cosine, sum formula. That's going to be cosine of the first, cosine of the second, minus sine of the first, sine of the second. So I'm going cosine 30 times cosine 45. Put some parentheses in here so I remember. And that's not CVS, that's cosine. And then in between them, I had to subtract sine of 30, cosine 45. Very good. So now I actually have to fill in some values. The cosine of 30, hopefully we can all now get to pretty easily, the square root of 3 over 2. Cosine of 45, square root of 2 over 2. Minus sine of 30, it's going to be 1/2. And the cosine of 45, square root of 2 over 2. Now I have multiplication in between here, and I have subtraction in between. So let's multiply the parts on the outside first. Multiplying 2 radicals together is fine. Square root of 6 over 4 minus square root of 2 over 4. Now, when I subtract radicals, is it okay for me to combine them the same way that I did when I was multiplying them? No. I do have a common denominator for the fractions, though. So a 4 is fine on the bottom. I just can't do anything with this. Square root of 6 minus the square root of 2, and that's as far as I can go. That would be the exact value for the cosine of 75 degrees. All right. Now for our second one, let's take a look at using radian values. So we're doing sine of pi over 12. Now because this is a fraction, I'm sure this is going to be more difficult for some people to break it up into 2 things that you might not, 2 things that you do know. But if you think about the number 12 and the types of radian values that we have things like pi over 6, pi over 3, pi over 4. So if you're looking to try and match up some of those, the ones that work the best would be a pi over 3 and a pi over 4, because their common denominator would be a 12 if you're trying to combine them. So it turns out that pi over 3 minus pi over 4 actually equals pi over 12. So that's what we're going to be looking at here. So I'm going to go back. I'm doing a sine formula. We're subtracting them. So that's going to look like sine of the first, cosine of the second, minus cosine of the first, sine of the second. Oops, went back again. So let's do it. I'm going to do sine pi over 3 times the cosine pi over 4, and then minus cosine pi over 3 times the sine pi over 4. Now I can start evaluating sine of pi over 3, square root of 3 over 2, cosine pi over 4, square root of 2 over 2, minus cosine pi over 3, which is 1/2, and sine of pi over 4, which is the square root of 2 over 2. Now, you might start to see some similarities here. It turns out the cosine of 75 degrees is in fact the same thing as the sine of pi over 12. We're going to see the same types of multiplication happening here. I'm going to get the square root of 6 over 4 minus the square root of 2 over 4, which is going to evaluate to the square root of 6 minus the square root of 2 over 4. Beautiful. So using these sum and difference formulas really isn't that hard. It's figuring out what numbers you want to use to break up that value. The next example that I want to look at is using the sum and difference formulas in a geometric setting. So what I want to do is write cosine of the arctangent 1 plus arc cosine of x as an algebraic expression. So, first off, you might be looking at this and saying, okay, cosine of, and then a whole ton of stuff that just seems like it's way too much to deal with. And I get that, but all we need to recognize here is that I have the cosine and I'm doing a sum on the inside here. If I'm doing a sum and I'm using cosine, I'm going to go back to my thing here. It's going to be cosine of the first, cosine of the second, minus sine of the first, sine of the second. Okay, so let's see if we can work that out. Cosine of the first, cosine of arctangent 1.
Want a Rice Krispie?
And then times the cosine of the second, times cosine, arc cosine of x. And then minus sine of the first, sine of arctangent 1, times the sine of the second, sine of arc cosine x. Alrighty, so what has that really accomplished? Well, it helps us to try and figure out what values we can put in here. I'm looking for the cosine of arctangent 1. Now I'm going to get that from these figures down here. Okay, I have what this is actually. This is cosine u plus v essentially. Okay, so when I say cosine of arctangent 1, what I'm really looking at is 1 over the square root of 2. When I say cosine of arc cosine x, what I'm doing is cosine, arc cosine, those two things are inverses of each other, so that's just x. When I see sine of arctangent 1, what I'm really looking at is 1 over the square root of 2. And when I say sine of arc cosine x, what I'm really looking at is square root of 1 minus x squared. Once all of that's figured out, it's really a lot simpler to try and simplify the whole thing. I have x over the square root of 2 minus, let's see, the square root of 1 minus x squared over square root of 2. Fantastic. I have the same denominator, so that makes it easy. X minus square root of 1 minus x squared over square root of 2 when I combine it all. And that's pretty much as simplified as I can get it. It looks extremely messy. But I have written the cosine of arctangent 1 plus the arc cosine of x as an algebraic expression. All right, that's given the idea that u is equal to arctangent 1 right here, that we're doing u plus v, and v was arc cosine of x. All right, so we were able to take these things and expand it out and then evaluate these numbers using the figures that are below. Okay, so that, I believe, is all for this. This is an extremely complex version, by the way. Most of what you will be doing is this. So that's basically it for sum and difference formulas. It's a nice quick one. It's just a matter of using the formulas in the correct way and evaluating the sine and cosines correctly, and splitting up the angular values. So good luck, fare thee well, and have a good time!
Well, this is fun.